I'm Logan Crawford, and right now on Spotlight, we're exploring the groundbreaking field of artificial intelligence with Shahab Mohaghegh, author of Artificial Intelligence for Science and Engineering Applications. This fascinating book dives into how AI can model physical phenomena and solve complex problems in science and engineering. If you're curious about AI's potential to revolutionize these fields, you won't want to miss this insightful discussion. We're delighted to have this very talented author join us here today on Spotlight. We thank the team at Books to Life Marketing for helping us put him in the spotlight today. And we ask viewers like you to support authors like him by subscribing to our channel and by purchasing this amazing book. The links are below this interview. Shahab, thank you so much for joining us here today on Spotlight.
My pleasure. Thank you.
Let's talk about how AI in science and engineering differ from its use in other industries.
The fact is that the first and foremost, in order to truly understand that how it works, has to do with the definition, the realistic definition of artificial intelligence, the definition that was developed by the scientists that created this technology, not by our own idea what the AI definition is. So the reality definition of AI that is developed by a lot of scientists in the 50s and 55 is artificial intelligence simulates human intelligence, and it does it through mimicking human brain. So this is very, very simple, but incredibly important that artificial intelligence simulates human intelligence. And how does it do it? It doesn't do it extremely from mimicking human brain. This is so important because when this is true, then it's very interesting to go through engineering and science for human. Then you see the same thing. It's interested in human intelligence. That's how AI, artificial intelligence, is doing it. For example, I always tell people, because a lot of people come to the conclusion that in order to do AI for engineering, they need to hire an AI expert, which is fantastic, an AI expert. However, their engineering application is very little or none. And
Hmm.
then I ask them, okay, let me ask you a question. If you have this person, human person, that have been through school and university and working in a specific engineering process, you have this, and then you have another person with the same exactly the same how old they are together. However, this other person, let's say he has not been to the university and have not done that engineering. However, he is very good in general intelligence. However, he doesn't have the intelligence in engineering specifically that this other guy there. So if you have these two people, here's the question. If you want to solve an engineering specific issue for that, would you go to the guy that in human engineering expert or human only general expert? It is obvious everybody would go to human engineering expert. That is the idea. Then I said, okay, then why don't you think that the artificial general intelligence is different from artificial engineering intelligence? In other
Hmm.
words, when you are expert in AI, you must become an expert in engineering as well. Or vice versa. If you are expert in engineer, you also must become an expert in AI. And that's one of the major issue that overwhelming majority of the people in engineering working, they're using AI expertise with very little that are very little understanding of engineering, or engineering expert that have very little understanding of AI. That is what I mentioned based on what we have understood, that first and foremost, you must be an engineering expert. However, then you must become an AI expert, an artificial intelligence expert, not only just understanding the mathematical equation of the machine learning algorithm, then you know everything about AI. But that's not true. That is good for you to know, but that's only 20% of AI. There's so much other thing you have to learn about it. Then you become fantastic. Why? Because AI, overwhelming majority people do not think that artificial intelligence can model physics.
Mm.
When you go through all of these that I mentioned, you find out that AI can actually model the physics fantastically. Very different the way we as human did it in the past 400 years, where we had uh, 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 mm, started doing engineering modeling,
Mm.
and even it got better every year.
Right.
But we did it through mathematical equation, and we still
Mm.
do, which is fantastic. I'm not saying it's not good.
Yeah.
However, when AI does it, it doesn't use any mathematical equation. It doesn't use any assumptions. It doesn't use any interpretation. What it does, it uses all the actual measured data from a physical phenomenon, and then it models it based
Mm.
no assumptions, no interpretations, just because fact and reality, which, however, you must be an engineering expert to go through all that data,
Mm.
measure data when you and make sure it's good and correct, and there are some missing data, there is some bad data you have to throw away, and but AI can handle that fantastically, and the results it gets better results than we have done with mathematical equation in the past several years.
Amazing, amazing. How does AI enhance traditional scientific and engineering problem-solving methods?
It doesn't truly because of the actual measurement that has been done and what you're trying to find out the results are. You have that also as a measured data. However, let's say from in the past, you look at all of the measured data that it's perfectly fine and do it as input. How is the output? The output that you're trying to find out that that particular physics, how does it work? What does it do? And because in the past that exists, all of those measured what happened, what that physics does. You use that not as an input, you use that as an output. So you take all the measured data as input and all the things you want to happen in the future, you find out how to enhance it or make it better. You do that as the output in the past. And when you do that, AI goes through training and testing. However, in petroleum, sorry, not only petroleum engineering, in all engineering, we
Mm.
find out that because in general intelligence, artificial general intelligence, everything is done through by with the data that exists. They do it through training and testing. However, in engineering, definitely, you have to do that, but not only do that. What you have to do is do definitely training, testing, and you also have to do two more things. One is called uh, blind validation, meaning that whatever data that you have, in order to make sure that AI results is very, very, very good, the only way you cannot just trust it. What you have to do, take some actual data and put it away, part of it,
Mm.
and make that blind validation. Because when you do the AI testing and training and testing, and also another one which is validation, when you do all of that, the result do the data that you already had it, but you didn't use it into the
Mm.
training and the testing and the right. And then you say, okay, you forecast what happened, what's gonna if this data input is, what is the output is gonna be. And then you compare it with the output you already had, but you didn't provide it. And when that result is over 80, 85, 90, 95, 98% accuracy, then you can say, wow, we have done well. Because if you have not done that good, you have to keep changing it and learn more and change the machine learning deal
Mm.
with how you have to do with AI to get better and better and better. And then you get the results. That's why in engineering, we do definitely training, definitely testing. However, we do validation all within that. However, we do some blind validation that we put the data away to make sure that it works.
Amazing. Before we leave you today, I just wanted to ask you, what do you hope readers take away from your book?
Sorry, what? Say it
What do you
again.
hope readers learn or take away from your book?
Yeah, that's exactly. I go through all of this detail because the books that I have written, before this one that we are talking about, artificial intelligence for science and engineering application, all the books that I had written was application of AI in petroleum engineering.
Mhm.
However, what happened when I came across to a lot of people, because at the beginning, when I said 33 years ago, I started it. And then for honestly, for 10, 15 years at the beginning, when I was doing this, a lot of people didn't like what I was doing, or
Mm.
they thought, why are you? So the key is when Google and Amazon and all these companies brought in AI and did fantastic work, then people say, oh, let's see if it's going to help in engineering. However, the problem is they use exactly the same. They do it in general intelligence to do engineering. And when that happened, I found out, wow, there is this difference. And that's how I came up with the idea to write this book. When I
Mm.
heard what they do and what I was done in their long time, that they do not completely understand AI, or they do, if they are expert in petroleum, in any kind of engineering, or if they are 100% AI experts, they don't go through a detail of every engineering problem that they're trying to solve and go to become an expert in that. And this made me build this, or come this conclusion of this, sorry, come this book to
Mhm.
explain what is the difference between them and how you must do as an engineer in order to solve them. And then literally, I told two main things. One, something that nobody in engineering believes. One is that AI can model the physics itself, number one. Number two, there is a difference between artificial general intelligence and
Mhm.
artificial engineering intelligence. I went to so much detail and explained that in this book. What are the differences? How would AI model the physics, and all the details that I mentioned? That's why I did the book, because I know for a fact, in hopefully in the soon future, in the next few years, people will gonna go back and go into AI, learn it more and in engineering, and then they learn and they understand that it's gonna help so much. Everything that we have done in the past, it's gonna get quicker, it's gonna get faster, and it's gonna get results better than what we have done. That's what AI
Exactly. We
is
take
so
the
fantastic.
greatest brains in the world and put them on steroids, basically, harness them all together from Einstein to the greatest engineers and the greatest thinkers of all time. It is just amazing. It can be used as a wonderful benefit to
Yeah,
mankind and humankind. I think we are at the infancy of this. I think over the next 1 year, 2 years, 10 years, it's going to be mind blowing because what
absolutely.
AI can do right now blows my mind.
Yeah,
So I can't imagine it 5 years from now.
yeah, it
So
is
much
incredible
wonderful
technology.
information contained in this book. It is called Artificial Intelligence for Science and Engineering Applications. The book is a fascinating one that dives into how AI can model physical phenomena and
Exactly,
solve complex problems in
exactly,
science and engineering. Read
exactly.
this, understand it, understand that we're in the infancy, understand the wonderful things that AI is capable of doing and creating right now. Shahab, thank you so much for joining
Thank
us
you
here
so
today on
much.
Spotlight.
My pleasure. To be honest, last thing I always tell my students when I teach them, then your engineering that you're so happy with and you do great, once you get AI to do engineering, you get much, much, much better and
Oh,
much,
yeah.
much happy to do your engineering thing with AI. AI
Yep.
is absolutely fantastic for engineering. Thank you so much.
I think it's fantastic for every application, honestly. I
Absolutely.
mean, I can prompt it to write a novel and it'll write beautiful novel prose that'll bring tears to your eyes. It's amazing. It's just absolutely amazing phenomenon.
Pleasure.
Shahab, thank you so much for joining us here today on Spotlight.
My
To the
pleasure.
folks at home, I'm Logan Crawford, thanking you for your time this time. Until next time on
Thank you so
Spotlight.
much. Thank
Thank
you.
you.